I can explain Meeresvogel. I, unfortunately, not being a native German speaker, can't pronounce it as well as you, but I'll have a go. So the aim of Project Meeresvogel is to explore what I call the missing middle in weather graphics. And that's to say that there are plenty of tools for doing weather graphics within the meteorological community for the meteorological community that do very sort of detailed and highly technical outputs. And then there's also, at the other end of the spectrum, the tools that are used for producing weather output to show the general public, say, by broadcasters. And I've found as somebody that often wants to tell stories that have a weather-related component, that there's not really much in between to help us make these graphics to tell our stories. So although both these types of systems, I'm not questioning the validity or the usefulness, they're all brilliant. I thought it'd be nice to have something more in the middle to work with. Next slide, please. But this got me wondering, so, what kind of tools could I possibly make to allow people to make these kind of graphics without having to master the intricacies of a tool like MetView, which again, MetView is brilliant, I love it, but not everybody, especially people not involved in the meteorological community, have time to master it or the inclination to master it. Next slide, please. So who am I and why do I care about this and why do I think I'm well placed to do something about it? Professionally, I'm a web systems engineer and I have a passion for telling stories with data. I've done this for nearly 30 years. In a wide variety of domains, including artificial intelligence, arts, genomics, online gaming, finance, and of course, my favorite domain, meteorology. And I've worked with systems at both extremes I've described, both the ECMWF and the BBC Weather Centre. And in the picture, you can see me during my time at the Weather Centre. That was not broadcast. That was just something that we allowed the public to play around with when they did their tours at BBC. Next slide, please. Sorry. So also, I have a personal interest, or many would say obsession, with sailing, and in particular, solo ocean racing, which led me to depart my lovely colleagues at Shinfield Park in 2013 in order to attempt a 3,000-mile solo ocean race across the North Atlantic, which I eventually attempted in 2017 unsuccessfully, and I hope to complete successfully next year. This obsession also led me recently to move to the Atlantic coast of France, where I can more easily combine my personal and professional interests. Next slide, please. So the example I wanted to work with for my demos comes from an event which coincidentally, or maybe not entirely coincidentally, was happening just up the road from me when I moved here last November. And it's called the Vendée Globe Race. It's a quadrennial, non-stop round-the-world solo yacht race that starts, like I said, in Les Sables d'Olonne. And the last edition, we had 33 skippers from 9 countries who spent between 80 and 120 days each alone sailing their 60-foot boats around the world as fast as they could. And just to kind of, if you can imagine it, they had to be in full race mode 24/7 for the entire time, never sleeping more than 20 minutes at a time, mentally having to, physically having to do the equivalent of, say, a marathon or maybe even 2 each day. And again, like I said, not being able to recover because they didn't get to sleep very much, eating terrible food, having to mentally make all the navigational decisions, which involve downloading lots of gribs and studying the weather forecasts to try to decide where to go. And then they also had to troubleshoot any problems that happened on the boat in electrical systems or mechanical systems. And then, as if that's not enough, the race rules this year added that each competitor was required to send back a certain number of audiovisual assets as they went around the world. So they actually had to make videos and in many cases edit them on board themselves and conduct interviews. And yeah, so it was just, they were a lot, but it was an absolutely fascinating event to watch. And that might explain how it built a fan base of 11 million worldwide. And in France, there were 193,000 pieces of media coverage during this event. Next slide, please. So the main source of information was the site's own tracker, and which was brilliant. And me and everyone I knew and 11 million other people were absolutely glued to this for, morning to night for the entire 4 months of the race. And you could mouse over to see information, sort of instantaneous information about each boat. Well, kind of how fast they'd been going and things like that. If you could go to the next slide, you get a better view, sort of more zoomed in. Yeah, so telling you how far that each boat has to go and how fast they've been going, and then a little snippet of information about the current conditions around the boat, so air temperature, water temperature, wind, and waves. And then, as you can see underneath, the chart was showing 10-meter wind. And this is all really great, but I felt like it was missing something because on the other side of the website, which I haven't shown, was the collection of audio visual. So you could go through, and every day there would be videos from lots of skippers and interviews and audio podcasts. And so in the end, at the time, it was quite fun and engrossing to be consuming all this, but it was quite divorced. The human stories were quite divorced from kind of looking at the weather context on the chart. So I thought that I'd like to have a go at doing something better. So next slide, please. So my aim was to explore building a proof of concept demo with constructing some tools to help people create an enhanced race tracker using Google Earth. And when I say enhanced, the ways in which I tried to do this were by making better overlays, better mouse overs, links to the audiovisual content within the tracker itself, graphs incorporated into the presentation, and then finally fly-throughs. So I'm going to take each of these one at a time and show you what I did. So next slide, please. So as I kind of alluded to, the 10-meter wind is probably, for people that are following the racing aspect, one of the most important things, because to win you need to go fast, and to go fast you need to find the wind. But for people that aren't so interested in the technical aspects of the racing, something like this, which is 2-meter temperature, kind of helps people relate kind of the human experience of being on the boat to what we understand. So kind of we could picture these poor boats having to go through the tropics, and where it got extremely hot and there was no shade, and it was like an oven inside these carbon fiber boats. So this is kind of an interesting extra sort of enhancement, and it makes a layer that helps non-technical users sort of connect more to the experience of the skippers while looking at the track. And next slide, please. But for the sort of more esoteric sort of technical users, here's one that I built, which was an overview showing the Benjamin Fear Index. And this is something that is extremely interesting to me as somebody who's done a lot of ocean sailing and encountered quite scary sea state conditions. I learned about this from Peter Janssen, who was head of the Marine Aspects section, just around the time that I left the center. And I had the bad fortune to wander into an area of extreme sea state, and ended up losing my mast and nearly losing my boat to one of these. And when I talked about it with Peter afterwards, and he sort of went through, pulled up the charts from the archive, and he talked about the Benjamin Fear Index and how it was likely that I had in fact encountered a freak wave, and that one way that might be, that it would be interesting to sort of have more of a heads up about these sorts of phenomenon would be to look at this particular parameter. So it's interesting to me. I've found that even people I've talked to who work in ship routing are oftentimes not aware of this. I think it's something that deserves to have more exposure in the world of sort of ocean travel. But anyway, so this particular layer sort of shows the area of elevated freak wave risk as a sort of darker red. This, I didn't choose this. This was the ECMWF default styling for this parameter. I think it's quite apt because it makes it look a bit like stab wound, which, yeah, it can hurt to go through these kind of areas. But in this particular screen grab from Google Earth, you can see the two leading boats who are just charging through an area of quite elevated sea state and elevated risk of rogue waves. Next slide, please. And although I've turned off that overlay, this is kind of the same view without the overlay, where I've moused over a link to a video that was sort of published on that day by Thomas Royan, who was the second boat that was going through the really dark area of the rogue wave risk. And surprise, surprise, we have him on the video saying that it's the sea state that's been particularly nasty today. And elsewhere in the video, he talked about it being like a cauldron. So I feel like it kind of helps people to understand, you know, when they look at the charts of something, to be able to immediately click and get sort of testimony from the skippers or demonstrations of sort of what things are looking like to them at that point. Really adds to the engagement. And likewise, next slide, please. You can, is that the next slide? Okay, thank you. I added, I thought about the parameters that might be interested to have access to in the mouse over. So in this case, the mouse over linked out on that day, and you see, lo and behold, the Benjamin Fear Index is up at 0.6, and the significant wave height is over 4 meters. And keep in mind that when you see that significant wave height, 4 meters, what that actually is saying is you can expect regularly to see waves of up to double that, possibly more. So these are definitely, quite intimidating things to be encountering on a small boat out in the middle of the ocean. So again, these the parameters that you choose to show on the mouse overs, can be changed to suit the audience. So this, of course, will be something that the diehard fans will be interested in, but in other cases, you might want to just show, like the main tracker does, temperature, air temperature, sea temperature, for a less sophisticated audience, and not overwhelm them with lots of data. Next slide, please. Fly-throughs I did not get to do, but I'm really excited to figure this out and make some to share with people soon. So next slide. And finally, graphs. So I ended up using GeoPoints format to collect files for each boat's track for each parameter. And the lovely thing about that is MetView makes it very easy to make graphs of these. So here's one case where I'm showing, and this could be embedded into the presentation, of course, but I found this one really fascinating. It's the mean sea level pressure, which is kind of a proxy for how fast a boat can go, because areas of low pressure tend to have higher winds. So the really competitive boats will really see how close they can get to the center of depression to get an extra boost. But it's always a balancing act between sort of how strong wind you want to be in versus how difficult it is to manage the boat and get rest and things while in these stronger conditions. But this is showing the track mean sea level trace for pressure trace for the first boat to finish and the last boat to finish. And I think pretty much anybody can look at this and see that it's essentially the same kind of shape of curve, but in one case it's been compressed in that the first boat kind of got through the course faster, but it kind of shows that all the boats are going around the world, and so they're encountering more or less the same types of conditions, just at kind of different rates. And you can see here, in addition to it being faster, the red boat was sort of, you can see the valleys are deeper, and that's kind of indicative of his appetite for risk, that he was more willing to go closer to the centers of the lows. And also generally the values of his pressure values are lower sort of in general than the blue ones, who, so in this case, the competitor was a Finnish guy named Ari Husela, who's an amateur racer. He's an airline pilot, and so he has a very kind of measured, conservative, by his training and out of habit, a very conservative approach to risk. So you can see that he wasn't sort of going for it, sort of sailing into the middle of the lows constantly, like the first boat. Next slide, please. And here you have, again, two boats, but this is the first boat to finish and the third boat to finish. And it's just, I look at this and I just think it's amazing how similar they are. And it's kind of, to me, saying that these two skippers were very close as they raced around the course, and had very similar risk appetites, and that they, kind of went for the lows very much in a similar fashion. Although you can see that the red one, his lows in a number of cases are that much bit lower, which I think is what helped him get to the finish faster. And there are a couple interesting divergences in this graph, which I think tell a really interesting story. The first is around the end of November, when one of the competitors, Kevin Escoffier, was in some strong conditions, and his boat literally folded in half and sank, and he went into his life raft. So a number of the competitors who were nearby were diverted to go search for him in his life raft. And the blue boat, Metricock, was one of them. So you can see at that point, early December, where suddenly he goes off into a more high pressure area, and that's him kind of taking his foot off the throttle and going to look for Kevin. But he then sort of managed to catch up really well after they luckily found Kevin, and kind of was battling it out with the red boat for the rest of the course. And at the very end, you can see where he's kind of desperate to try to get ahead. And you can see him sort of going for it a bit, taking more risks. But he ended up, if you look on the tracker, he ended up going a bit north, sort of off the path, but in search of stronger wind to try to get ahead of the leader. And what ended up happening was, although the blue boat Metricock finished third, an international jury sort of awarded compensation for the time that he'd taken out to help in the search for Kevin Escoffier, and that time was sort of agreed soon after the incident. So throughout the race, he knew that he had this extra time that would get deducted from his finish, and that allowed him to win the race overall. So although he didn't finish first, he was the winner of this edition of the Vendée Globe. Next slide. And finally, this is possibly the most exciting slide in my opinion, but disguised as the most boring. It's a spreadsheet where, and this is one of the nice things that using the GeoPoints format allows, it's the competitors ranked by the percentage of time that they spent in the areas of low pressure under the 5th percentile and above. So I sort of looked at all of the pressure readings, found the 5% lowest ones, and then figured out how many of those belong to each competitor, and sort of normalized it by how long they actually took to do the race. And what ended up happening was I noticed that the top 10 finishers were the ones that were the sort of top 11, had the top 11 percentages of time spent in these relatively low pressure areas. And there's just one, Louis Burton, who was third, who got kind of bumped out of the top 10 spot by a boat who unfortunately didn't finish, and that was Isabel Josh on MACF, who had keel problems just after she came around Cape Horn. And what this says to me is that, I mean, it's really especially gutting for her, because I think this is kind of showing that she had a real potential to you know, finish very well, you know, possibly as well as fifth had she finished the race. But unfortunately, she was knocked out. But I just found this correlation extremely interesting, and it really sort of popped out at me. So I thought I'd share it. So finally, future plans. I'm going to finish the demo, so do some fly-throughs and share with people who might be interested, collect feedback, and to continue working on it and making it better. I need to document my code and make it easier for others. So at the moment, I kind of have descriptions of what I've done, how I've prepared all the data, how I've generated all the assets that could be followed by somebody, but it needs to be sort of written up more clearly. And I'd like to consider using other output formats such as Leaflet.js, or doing some demonstrations that are things not to do with sailing, something based on the land, perhaps. Next slide. And finally, I just wanted to say thanks. I couldn't have done this without the support of ECMWF, in particular the ESoWC team, and my mentors, Stefan Seaman and Ian Russell, and the MetView and Magix teams who've made these great tools, and especially the reanalysis team who've created ERA 5, which is amazing, and they don't get enough praise, I don't think, or credit for this amazing resource they've created for the world. Also, I'd like to thank the teams responsible for the Climate Data Store and the CDS API, which made it really easy to get the data. And then also Peter Janssen and the other members of the Marine Aspects section who put up with all my questions over the years about sea state. And then also just to thank Kevin Salyu at Regadata, who made it a lot easier for me to get the track coordinates for the boats, which on the official site are kind of buried in a weirdly formatted Excel. So thanks, Kevin, for saving me a lot of time, and the developers of the JQ utility. And oh, also, I forgot to put in here, but especially thank you to Florian, who has shown amazing leadership and encouraging ECMWF to be more innovative and open. And I think that's a really great development. So thanks.
Catherine, thank you so much for your great presentation and also sharing your project results with us. I find it always amazing how you can tell stories, and I was amazed that just based on a mean sea level pressure graph, with your work you can now infer specific characteristics of different sailors, whether they are more risk takers or more risk adverse. So thank you so much. I have one question. So once you finalized your developments and you made a documentation, will this then also be available for the public to be? Yes.
Yeah, and I apologize for not having everything up on GitHub, but I was trying to put it up and I found it was interfering with my my Zoom. So I will do that later this afternoon. So the code that I've done so far will be on the Meeresvogel ESoWC Git repository later today.
Okay, perfect. Thank you so much. And again, also thank you for being part of ESoWC ECMWF Summer of Weather Code this year. It's been great to have you and also your project, and thanks for your time today.